Ruchika beta, you are online?
Yes, sir.
Okay. Chavi beta, you are there?
Yes, sir.
Okay. Okay. And of course, Manan, you are there. Let's start beta. So we have quite a bit of ground to cover today. So we'll be focusing on two question types, number 19 and number 22. So number 19 and number 20, not 22, sorry, number 19 and 20. Just as a quick recap, uh, in the last few classes, we started with relative motion and relative motion in two dimensions. So in the previous class, in the Thursday class, the last Thursday class, we looked at a scenario where we had two objects or two particles moving with constant velocities in, say, xy space in two dimensions. And we worked out the method or the approach to find out the minimum distance between them. Minimum distance between them, right? So that was number 18. So let me just take a quick dive in just to see if there are any JEE advanced questions or NT Abhyas questions that we should look at. But then we will jump into number 19, wherein we will look at the Rainman problems or problems similar to the Rainman problems. And then, of course, number 20, swimmer introvert. So those are our focus areas. And let's see if we can do a good job on both of them. Okay. So number 18, we are revisiting, and let's do a problem or two just to warm up ourselves, and then we'll move forward. It seems to be taking a little bit longer time. Why is that? There we go. Okay. So let's quickly do one problem from JEE Mains, one problem from NT Abhyas, and one problem for JEE Advanced. Okay, let's get started. This one. Ship A is sailing towards northeast with velocity this much, where I points east and the J points north. Ship B is at a distance 80 kilometers east and 150 kilometers north of ship A and is sailing towards west at 10 kilometers per hour. A will be at a minimum distance from B in how many hours? Okay, please go ahead. For the viewers on the YouTube, you might wanna, if this problem seems a little bit tricky, you might wanna revisit the lecture on the last Thursday, lecture number 10, and see how we handle such problems. But once again, what you have to do is you have to figure out the relative velocity of ship A with respect to ship B or vice versa. That's fine. So let's say we're going to find the relative velocity of ship A with respect to ship B. Once we have done that, then you will notice that the relative velocity is not pointed in the relative position vector, in the direction of the relative position vector, right? Which means it's not going to be hitting ship B. So now we just need to figure out when ship A reaches, as seen by B, when does ship A reach the minimum distance from B? What will be the minimum distance? That will be the shortest distance from B along the relative, along the path or along the direction of motion or direction of relative motion of ship A with respect to B. In any case, if it did not make sense, not to worry. We will try and solve it, and then you can see how we actually solve such problems. So let me go back into the live class. Would you guys like me to solve this one? Or you guys are okay?
So 2.6.
2.6. Chika, Chavi, are we doing okay, beta?
Yes, sir. Yes, sir. 2.6 आ गया.
Okay. Is that how you guys approached it as well?
Yes, sir.
Okay. So what is this? What does this come out to be, beta? The distance
So 17
70,
into 10.
170 kilometers. What does this angle theta come out to be? Or beta, what was the? Acha, what is the cos theta? What did you get as the cos theta?
So मैंने different way से करा ना.
कैसे किया बेटा?
Sir, after time t sir हम shift A के coordinates से 30 t I cap plus 50 t j cap.
Okay.
सर और फिर शिप भी सर अभी उस ए के रिस्पेक्ट में 80 किलोमीटर ईस्ट है सर वेस्ट आ रही है सर तो उसको लिख सकते हैं 80 माइनस 10 टी एंड 150 टी एंड सॉरी सर 150.
Acha, so you did not use the relative motion, but rather you worked in the reference frame, the ground's reference frame, right?
Yes.
So okay, so how did you figure out Acha, you figured out the minimum distance. How did you figure out beta what this?
सर सर कोऑर्डिनेट्स अब टाइम टी निकल गए सर जनरल फॉर्मूला निकल गया उसका.
Okay.
सर फिर डिस्टेंस फॉर्मूला लगा के सर डिस्टेंस आ गया सर फिर डिफरेंशिएट करा विद रिस्पेक्ट टू टाइम उसको 0 रख दिया.
That's good. That's good. Excellent. So let's do both the approaches. Shall we do it? Chavi, beta, aapka, where are you now? Almost done?
Yes, sir.
Okay. And Ruchika, beta, how have you done it?
Sir, I've done an error here, so I'm not sure if it's correct or not. So just a second.
Okay. Manan, are you able to follow how we are doing it when you active motion?
Yes, sir.
So let me just quickly write what is RA minus RB. RA minus RB is your minus, is it 80 kilometers? Minus 80I minus, what was this distance? 150 kilometers minus 150J. VB minus VA, we have already done that. So what is their dot product? So their dot product is, so I'm going to take 100 out. So I'll be left with 4832 plus 15575. And unless I've done some error here, you guys can tell me. So this is square root of 40 square plus 50 square. And what is the magnitude of this one? This is 10 square root.
Sir, इसका 170.
We have already done this. Yes, this is already calculated here. This is 170. This 170 and the other one will cancel out. How much is the VB minus VA? This is square root of 16 plus 25. That is
So 10 root 40.
10 root
40.
10 root 40. Wow, these numbers are not that easy and straightforward. But in any case, we want to divide it by VB minus VA, right, to get the time. And we'll do square of this. In fact, I'm going to do 10 cross 41 here. So this will be, this should give us the time. So it will be, so I'm going to cancel out this 10 as well. So what do we have here? We have 107 in the numerator and we have 41 down below. Is that what you had as well, beta? 107 and 41? So I'm just using a calculator to figure this out. That comes out to be 2.6. Chavi, beta, we are okay? Yes, beta? Ruchika?
सर एक बार cos theta वाला पार्ट समझा सकते हो?
Acha beta. Cos theta is, we're trying to figure this this angle out. So we have two vectors. So this angle is between what vector and what vector? This is between this vector, which is along the direction of VB minus VA. Right. So this is my VB minus VA, and then the other vector is RA minus RB. So if we know these two vectors, how do we find the angle between them? So recall if you have A dot B, can write this as ax ax bx plus ay by, or you can write this as magnitude of a magnitude of b times cosine of theta. So what is cos theta? Their dot product in unit vector notation divided by their magnitudes. So cos theta is ax bx plus ay by divided by ab. Now we will try out Manan's method and see if we can get to the same result. And we'll see if it gives us some advantage from time perspective as well. Clear, beta? Chavi? Yes, beta?
Yes, sir.
Okay. Let's move forward. Now, the other approach. So what Manan has done is, Manan said, okay, so let's say whatever the coordinates, this is my point A, whatever its initial coordinates, we know the coordinates of B relative to it, it is this one, 150.
So मैंने एक origin पे मान लिया था.
That's fine. एक आप origin पे मान सकते हैं, no worries. So in fact, let's do that. Or let me keep it origin. It will not really matter. We'll see the coordinates of A will quickly cancel out. But origin is a good choice from the speed perspective. So 80 kilometer east, sorry, not the 150 kilometers. So we have 80 kilometer east and we have 150 kilometers north of Shipay. So it is traveling in certain direction given by 30i plus 50j. So what will be the coordinates of A? What will be the position vector of A at time t? At time t. So that will be xa plus 30t. As far as the y coordinates, ya plus 50t. Is that right? Ruchika, Chavi?
Yes, sir.
Now let's write down the coordinates of B. B ki velocity is in, B is moving towards the west direction. So it is, what is the speed? 10 kilometers. So minus 10 kilometers per hour. So your RB then is XA plus 80 minus 10. Right. As far as y coordinates is concerned, y coordinate will not change. It will remain the same. YA plus 150. There is no t in there. What we are trying to figure out is their relative position or the distance between the two. So how do we find the distance between the two? The position vector, relative position vector is, let's say, RA minus RB. Position vector of A with respect to B, or you can do the vice versa, RB minus RA. Either way is fine. We're only interested in the magnitude. So what will this be? It will be RA minus RB. So what do we get? The XA will cancel out. We will get minus 80 plus 40t I cap plus YA plus 50t minus YA minus 150. So YA cancels out. So we get minus 150 plus 50t J cap. So what is the magnitude? Magnitude is, so by the way, what I've written here is not the magnitude. I've written the vector itself. So as far as the magnitude is concerned, that will be square of the x component plus square of the y component, and then we take the square root of the sum. That is square root of minus 80 plus 40t square plus minus 50 plus 50t squared. Okay. Now, we are trying to figure out at what time R would be minimum, right? When is this R minimum? Well, we see that R depends on time. So we'll differentiate R with respect to time t, equate that to 0. Okay. So when we do that, what will we have?
सर इसमें एक और चीज कर सकते हैं.
Yes, बेटा.
सर इसमें अगर आर स्क्वायर को डिफरेंशिएट करें तो सर तो आ जाएगा 2r dr/dt. सर और 2r 0 हो नहीं सकता, तो सर तो वही कंडीशन बन जाएगी जो dr/dt से बन रही है. तो कैलकुलेशन इजी हो जाएगा इससे.
That is correct. That is absolutely correct. Yes. So, but I'll still do it this way, Manan. So you can quickly see how it's not going to be too scary, right? So that 2r will come down now, right? So 1 by 2 square root of everything. Yes. Which is what you are saying. This is what you have done. You just taken this part, you have kept it on the left hand side, right? This is r, no?
Yes, sir.
Now we differentiate what we have inside the square root. So what do we get? So we'll get 2 minus 80 plus 40t into 40 plus 2 into minus 150 plus 50t into 50, and equate that to 0. So what do we have? Let me see if I can write it neatly here. So I'm going to cancel out all 2's. When we equate that to 0, I'm going to cancel out the zeros. I'm going to cancel out the zeros from here as well. So what do we have? So we have minus 15 plus 5t multiplied by 5 plus minus 8 plus 4t multiplied by 4 is 0. So let's quickly settle down the terms. So 5 is 25. 25 plus 16 t is equals to, so we have 4 at 32. 32 plus 7.
107.
107. So time t is 107 divided by
40.
40. Okay, Vida. I am very happy and glad, Manan, that you did it this way, because while we are training ourselves for the use of relative motion, but we could have very well done it through this method as well, where we are working in the stationary reference frame or reference frame attached to the graph. Ruchika, Chavi, any comments here, beta?
Yes, sir.
Clear, no? Chavi, beta, did it make sense?
Yes, sir.
Okay. Let's move on. Let's quickly see what does NTFS have in there for us. Let me just quickly check to see if this problem is going to give us anything different. It says two particles A and B are located at points this and this in the xy plane. They start moving simultaneously at time t equals to 0 with constant velocities this and this respectively. The time when they are closest to each other is found to be. I think we have done this problem. This was part of the sample questions that we have. Correct? No? We did that yesterday, or not yesterday, Friday or whenever we did that. The chemistry class we had. Do you guys recognize it? Can we move forward?
Yes.
Yes, sir.
Okay. Let's solve this one. JEE Advanced 2014 question. Let me just quickly see if there's any comments here on YouTube. There are no comments, so we'll keep moving.
सर इसका बी है
The 5 seconds.
यस सर
Okay.
सर इसमें वीवी कैसे निकलेगा
इसमें VB कैसे निकलेगा?
यस सर
This is VB. VB, what is this angle? 30 degrees,
यस सर
right? So, uh, from the perspective of A, right, what does it see? That it's moving directly towards it. So, what is the other way to look at it? That both have, also has the same velocity in the direction of, in the direction parallel to the A's path of travel. That means along this path, B must be having the same velocity, no? Otherwise, that it's actually moving ahead of it, right?
यस सर
Right. So VB cos 30 is VA. So which means
Sir, I didn't understand this.
I see. Okay. So beta, so A is, let me just draw it for a different color. So A is moving along this direction. Correct, no beta?
Yes, sir.
Now B's path is this. Correct, no beta?
Yes, sir.
Now, what does A sees? Initially at time t equals to 0, A sees that B is here, right? Then what does it notice? What does it feel? That now the B is moving exactly towards it, right? Exactly towards it. So what does it mean? This is a different way of looking at the same situation. That if I were to draw a line parallel to the path of travel of A, right? Then when A reaches here, then B should at least have covered this. B of course has covered this distance now, same as that of A.
Yes.
Then they can meet, no? Yes, no?
Yes, sir.
Chosen a coordinate system with origin at A, one axis in the direction of motion of A, another perpendicular to it, right? Now what we are saying is, if B is to meet A at this point, then B has to cover this distance and then this distance. Correct, no? This distance is given to be 500 meters. And both A and B will be covering the same distance. Otherwise, how can the two meet? They will not meet. They will miss each other. Yes?
Yes, sir.
Okay. I'm using that logic to say VB cos theta or cos 30 is equals to A. So VB is equals to VA, which is 100 root 3 divided by cos of 30. Cos 30 is root 3 by 2, so it's 200 seconds. So now we are interested in the component of the velocity in the direction of A towards A.
सर इसमें बस एक्स डायरेक्शन में वर्क नहीं कर सकते
In what direction, sorry?
सर एक्स डायरेक्शन
X direction. Which one is the X direction? This is the X direction you are referring to, or this is the X direction?
सर राइट वर्ड
ये वाली.
यस
Okay. So what is the point? Can we not work in this?
सर इसमें सर 500 इक्वल्स टू VA cos 30 minus VB cos 60 into T.
Say it one more time, beta.
Sir, 500
Mm-hmm.
equals to VA cos 30 minus VB cos 60 into T. So that's the time of arrival, time of meeting नहीं मिल सकता.
So let's quickly figure this out. What you've done here is VA cos 30, VA cos 30. Oh, along the x direction, cos 30, I see. And VB cos 60. Okay. This is equals to but beta 500 is not along the x direction, no?
सर वो किसके होंगे?
Beta at time t equals to 0, they are somewhere in the space. You don't know where they are. You just know that the distance between them is 500.
अच्छा सर,
Yes?
समझ रहे हो हॉरिजॉन्टल लाइन का?
Oh, no. Have they said that? No, they have just said with respect to the horizontal, they make their path.
नो सर.
Now it doesn't say that they are both along the same horizontal line. It does not say that anywhere. So anyway, let's complete the math here. So what do we get? So VB sines 30 is equals to 100 meters per second. The time comes out to be 5 seconds, which is interesting. So let's revisit what you have written here. This is equals to 0.
सर इससे 5 सेकंड नहीं आएगा सर जो मैंने लिखा है.
You will not get the 5 seconds. Okay. Then how did you figure out?
सर मैंने ऐसा करा सर मेरा VB आया नहीं था. सर मेरा VB नहीं आया था. सर मैंने इसमें सर मैंने T निकाला सर. फिर सर VB सर T कभी 379 नहीं सकता. उसके लिए VB के अपसर्ड वाली आएगी. तो 5 है.
You reverse engineered the problem, huh? Just like the Chinese. These days, they don't do much reverse engineering. They are innovating.
Yes, sir.
That's not a very good dialogue there. They are definitely far ahead these days. Chavi beta. Yes, beta Chavi.
Yes, sir.
Okay,
Sir?
that's not a very convincing yes. So you got it, beta, or shall I look at it from a different angle?
No, sir, I got it.
Okay.
Yes, sir.
Okay.
Sir, I didn't get what Manas did, the other thing.
Oh, this one? What Manan did?
Yeah, Manan. Sorry, there's a guy called Manas in my class. I got confused. Yes, sir. I didn't understand.
So, beta, Manan was trying to. So, this is not correct, by the way. This is not correct. What he was asking was, is 500 along? So, looking at this image, he assumed that at time t equals to 0, they were here. Correct? So at time t equals to 0, Manan assumed that they were here, and then he worked out that okay, if they keep moving like this and they meet at somewhere at this place, then VB cos 60 minus VA cos 30 must into times t must be equals to this distance, which is 500. That's what he assumed. Again, the challenge would be you have two variables, you have t, and you still have to figure out what VB is.
Okay, sir. Yeah.
Yes, Vidhan? Okay. Interesting problem now. Ruchika beta, you will remember it?
Yes, sir.
I shouldn't say remember it. We don't want to remember any questions, but you know what I mean. Okay, let's move on. So we'll look at the Rainman problems, or rather I should say scenarios wherein we have to find the relative velocity of one particle with respect to the other. in the previous problem, which is actually, previous problem was one step ahead of this problem, where we had to figure out the relative velocity and then figure out the time it will take to get to the minimum distance and whatnot. But there you could still solve it or still solve that problem in the stationary reference frame. But here the question will specifically ask you to determine the relative velocity or acceleration, relative velocity or relative acceleration of one particle with respect to the other. Okay. So how do we do that? So let's start with and we have done the Rainman problem, right? So we discussed how we approach the Rainman problem. Rainman problem is that's exactly what we're trying to do. So let me explain how that problem is essentially finding relative velocity. So what do we have in the Rainman problem? We will be given that the raindrops are falling downwards. Now they might be falling vertically downwards, or they might be falling at an angle with the vertical, right? It can be this angle. They might be falling like this. And then you will have a man who's traveling, let's say, in this direction from left to right. Then the questions might ask you what will be the relative angle of, or what will be the angle of drop, right? What will be the angle that the velocity vector of the rain makes with the vertical as seen by the man, right? So essentially they are asking about the direction of the relative velocity vector. So if this is V man, let's say this is V rain. Let's look at the scenarios A, B, and C separately. So how do we find the relative velocity? They call for two particles, A and B. The relative velocity of A with respect to B is VA vector minus VB vector. Now graphically, the alternate way of saying that is add VA to minus VB vector, right? Add these two vectors. So we know the V rain. So in this scenario, this is my V rain, and this is minus V man. And this is V rain. The resultant vector is this, V relative. So if the question says, what is the angle that it makes with the vertical? They're asking us to determine this angle. Once we have figured out what the V relative is, then let's say this angle is, let's call it theta. Then the tan theta would essentially be your V relative x divided by V relative y. Correct, Namita? Got it? Same thing here as well. And same thing here as well. C is relatively straightforward. So if this is your V rain, your V man, sorry, not V man, rather I should say minus V man. And if somebody says, what is this angle that the relative velocity of the raindrops make with the vertical as seen by the man, as reported by the man would report that the raindrops are falling at an angle of theta. When what is theta? Theta can be written as V man, magnitude of V man divided by, or I should say V rain. This is V rain. So V rain, V man divided by V rain. Okay? Where V man, V rain is the magnitude of the velocities of man and rain. Any questions on this front? Let's go ahead and solve a problem or two. Let's look at this problem. It's a JEE Main 2022 problem, attempt. And I'm going to go ahead and race you guys for this question, okay? There we go.
Sir, my answer is coming out to be 15 root 2.
Okay. (15√2).
Yes, sir, it's not in the options.
It's not in the option.
So was 30 by root 2 shall 15 root 2 होता है.
Yes, sir, so फिर C हो जाएगा.
Sorry, beta, how did... okay, I see.
This is 15 root 2 only.
There is a bit of a learning lesson there, right, Ruchika?
Yes, sir.
Okay.
Oh, yes, sir.
Clear na, beta? The speed of the raindrops is, so the raindrop have horizontal component which is 15 root 2 and a vertical component which is 15 root 2. Did I do that wrong?
No, sir.
No, I'm getting it as 30, Ruchika.
Sir, with respect to what, sir?
Oh, with respect to the moving gun, I see. Then it's 15 root 2, of course. The speed of the raindrops with respect to the moving gun. Okay. So then they're interested in the vertical component. So everybody बिल्कुल clear?
Yes, sir.
Okay. Let's go to the next one. Let's do this one.
Sir, B option.
Okay.
Yes, sir.
Maybe beta, can you see an issue with my how I've done it? Root 3 by 2. Oh, sorry. Root 3. Beta is coming out to be negative, is it? Or have I done something funny here?
Sir, I'm getting 1 plus beta is equals to root 3.
1 plus beta is equals to root 3.
Yes, sir.
Yes, sir.
Ah, sorry. When I
The
combine,
tan 60 will be root 3.
no, when I combine 1 and 2, that's where I messed it up. My wrong. My wrong. So it's actually 1041 is equals to
Sir,
10.
1 plus beta into V, sir, V tan 60 आ जाएगा.
Right. This is what I should have written. So beta then comes out to be root 3 minus 1. Shall we, beta? We are good here?
हाँ सर हो गया.
Okay, good. Excellent, beta. Excellent. Rujika, good job. Manan, good job, beta. Chavi, good job. Let's take a look at the anti-abhyas problem. If you find something interesting, an attempt. Otherwise, we'll not do it just for the sake of doing it. A car A is moving with speed this much along a straight line 30 degree north of east. Okay, and another car B is moving with the same speed along a straight line 30 degrees south. Right? You guys clear how the 30 degrees is being measured? 30 degrees north of east. Right? So if east is towards the right, towards in the horizontal direction, then it's making 30 degrees with the east in the counterclockwise direction. Let me quickly draw it. So for this one, this is, if this is the travel, direction of travel, then this is 30 degrees north of east. The other one would be 30 degrees south of east. The relative velocity should be fairly simple and straightforward. Now let's go ahead and look at the next one, next question type. I do want to finish that question types. We might go 5 to 10 minutes more, but it's important that we finish that. Okay, so are you guys familiar with the swimmer in river problem? Chavi Beta, have you done that in center? Ruchika?
Yes, sir, we've done it.
Yes. So let's look at the three different scenarios, three different types of questions you can expect when involving scenario of a swimmer in a river or a plane flying in a windy conditions, right? Aeroplane flying in windy conditions. That means the wind is blowing at certain speed. You'll be given the speed of the plane relative to the wind. So it's exactly the same as the swimmer in river problem. So what do we have in swimmer in river problem? Um, we are typically we are given the speed of the swimmer relative to the river. Why do they say relative to the river? Well, once the swimmer gets into the river, he will not even realize unless he looks at the shores that the river is actually moving. So he's gonna swim relative to the water. Now, with respect to the ground, its velocity, his velocity would be the velocity with respect to the river plus the velocity of the river. So let me rewrite it. So we recall how we defined V relative. Let's say V swimmer with respect to ground minus V river. In other words, what is the velocity vector of swimmer with respect to ground? There will be sum of these two vectors, V relative plus V river. So let's look at the three scenarios. We don't need to be that methodical with the vector algebra here. If we simply use the common sense, we should be able to tackle these problems. So in the first scenario, we'll be given the starting point and we will be given the landing point, and we will be given the speed of the swimmer with respect to the water, and we will be given the speed of the river, and will be asked to determine at what angle should the swimmer be swimming to reach the destination, to reach uh, the landing point. In other words, by the way, I marked the wrong one. This is the V relative speed or relative speed of the swimmer with respect to the water. So now let's say if he is traveling in this direction with respect to the river, right? With respect to the river, he is trying to go straight, but then the current is flowing, it adds this distance or it adds this velocity vector. So the resultant with respect to the ground, it is this vector, V swimmer. V swimmer with respect to the ground. Okay. So you might be asked to determine at what angle from the vertical should he set off. So by vertical, let me explain. So let's say this is the starting point, this is the landing point, and we are given the V relative, and we're given V river. So we might be asked to figure out this angle theta, right? So we can figure that out now. That's a fairly simple, straightforward. If we are given this angle alpha, how would we do it? Can you guys tell me the expression for theta in terms of alpha? And of course, V relative and V river. So once again, let me draw the velocity vectors.
So theta बताना.
Theta in terms of alpha, V river, and V relative.
So theta कौन सा वाला angle?
That the swimmer makes with the line perpendicular to the shore. Yes, please. We did this. Would you use this equation to figure out angle theta? Okay, let's look at the second scenario. So in the second scenario, let's see what do we have here. In the second scenario, you might be given that the starting point and the landing point is directly opposite to the starting point. Then at what angle? From that line perpendicular to the shore should the swimmer set off swimming into the river such that he or she reaches the landing point just opposite to the starting point? Fairly simple and straightforward here. Correct, no, beta? Sine theta is V river by V relative. Correct, no?
Yes, sir.
In the next one, this is an interesting scenario. So here you would be given that the landing point is there, and so the swimmer wants to land there, and the question is the what is the smallest V relative? What is the smallest V relative with which the swimmer should swim so as to get to that landing point? So let me see if I can correct the statement. So we want to get there. So this is starting point. We know the landing point and we know V river. And the question is, what will be the minimum speed with which the swimmer should swim such that he or she reaches at that landing point? In fact, the number E that I did actually is in this problem in some ways, not entirely. Okay, let me repeat the scenario number 3. In scenario 3, what do we have is We are given the landing point, we are given the starting point, we know the angle alpha that this line joining the 2 points makes with the horizontal. And the question is, given the V river, what should be the minimum speed that the swimmer should swim relative to the river so as to get to the landing point? Did it make sense? Let me go around the room and see if it made sense. Chavi beta, did it make sense?
सर एक बार क्या क्या चीजें हमें पता है थर्ड वाले में?
Third wale mein, we are given the angle alpha. The line joining the landing point and starting point makes with the horizontal. No V river, that's it. And we are asked to determine the minimum speed, relative speed, which the swimmer should swim such that he or she reaches that landing.
First landing point, कौन सा point है? इस figure में.
What is it, beta?
Sir, इस figure में landing point कौन सा है?
Landing point is this one, beta. This is the starting point. So once again, what are we given? So let me circle those things that are given. This is given. This is given. These two things are given. Now, interesting thing is, to travel in this direction, the swimmer can swim in different ways, right? Let's say he can use a different color. Perhaps I can use a lighter color. Let me use light green. He can swim off like this. He can start to swim off in a direction perpendicular to the shore, right? And then relative to the river, and then plus V river, that will get to the same landing point. Or he can, or he or she can travel this way. So again, the vector sum of this V relative, V swimmer will still get you V swimmer in this direction, right? Now, what about, so the question is, what will be the V relative? Minimum V relative when the swimmer swims off in a direction perpendicular to the desired or the final direction of approach relative to the ground, right? So perpendicular to this line, if he swims, then the required would be minimum to get to that landing. He needs to swim at the least speed in that scenario to get to the landing.
So that would be V swimmer.
Which one, beta? This one. This is the relative speed of the swimmer with respect to water, with respect to river. This V swimmer is the net speed. It is just to show you the direction.
So when they say that the swimmer starts to swim with this angle, they mean the angle with which the swimmer speed is with respect to the ground, right?
Right. So let me actually revisit it and let me see if I can make it simple. The question is like this. So Chavi, use your name, okay? No particular this thing, just for the convenience. So Chavi beta, so let's say we are given that the swimmer starts here, have to land here, which means that the net speed relative to the ground should be in this direction. Correct, no? Yes, beta?
Yes, sir.
Should be the final, the net direction of travel back to the ground. Net, final direction of the travel with respect to the ground. So this is V swimmer with respect to the ground. So this is the direction of that vector, V swimmer with respect to the ground. Now we have to figure out the minimum relative speed with which the swimmer should swim in the water. What are we given? We are given V river. We are given V river. We are given this direction alpha. We have to figure this piece out. How much is V relative minimum? Okay. So what are the different ways he or she can travel? He can start here, let's say in this direction. Let me say, so he can travel like this, no? If this is V river. Yes, beta? Correct, no?
Yes, sir.
Or he or she can start to travel, let's say, in this direction. So let me use in this direction. Yes, still they will, the final direction will be, final direction of approach would be this one, in this direction. Yes, this is V. This is V. What are the scenario we can have? The swimmer might decide to travel, let's say, in, it's getting crowded here. Let me just erase them and let me redraw another scenario. Travel like this. They can travel like this. In every scenario, the final or the velocity with respect to ground is in this direction, right? Along the desired direction. Correct, Namita? The question is saying what would be, in which scenario would the speed, required speed be minimum? It will be minimum if he travels perpendicular. Okay. Why? Because if he travels like this, yes, Peter? Then all these scenarios, look at the this magnitude. So in what scenario would this V relative be minimum? This V relative will be minimum. This is perpendicular. To make the point, let's use this diagram. Right. So what we're saying is this is where we want to be, right? This is my V river. So let's freeze this vector for now. And now, how many ways can you travel in this direction? This is scenario number one, where the final speed is only this much. This is V relative, and this is V river. Correct? That's one diagram. Yes. The other one is, this is my final speed. This is V relative, and this is V river. Still, the final direction is along the desired direction, shown by indicated by the dotted line here. Or he or she can travel off. Let's say at a direction perpendicular. So if they travel in the perpendicular direction, this is the V river. The net speed is fairly high, right? The fairly high speed. Still, final direction is in this direction, right? So in what scenario can you see just by simple geometry that V relative would be minimum? These are all, the dotted lines are all V relative. V relative is minimum when V relative is perpendicular to the desired direction, desired final direction of approach. Too many words. I know I'm sure it must be very confusing. So let me understand whether it made sense or not. Otherwise, I'll change my approach in how I'm trying to explain it. Chavi beta, is it making sense? Yes or no?
Yes, sir.
Scale of 1 to 4. Be very honest, beta. Where are we? 5 means absolutely got it.
So like 4.5.
4. That's fairly good. Ruchika beta.
So same 4.5.
Okay. Manan.
सर मुझे ये समझ नहीं आया सर कि वो परपेंडिकुलर से क्यों हुआ मिनिमम
Oh, for the minimum, why will it be perpendicular? I see. Let's redo it. Let me change my approach bit. Let's freeze the V river vector. Okay, Manan? V river is given fixed value, and we know the direction it's moving from, let's say from left to right. It's not changing. Clear?
Yes, sir.
Is it clear? No?
Yes, sir.
Okay. Now we know we want the final velocity vector to be in this direction. That part is clear as well?
Yes, sir.
Okay. Now it's a fairly simple vector algebra, right? So what are the different ways we can do it? What about this scenario? This is my V relative. Correct? In this scenario, what is my final vector? This is my V swimmer. But the final vector is in this desired direction. Correct, Nanda?
So V relative की जगह V swimmer में ना swimmer.
Acha beta, let's understand what we mean by V swimmer. V relative is the speed of the swimmer with respect to river, with respect to water. V swimmer, this one, is the velocity of the swimmer as seen by an observer on the ground.
Yes.
Yes, no?
Yes.
Okay. And let's draw some other scenario. I'm going to use a different color here. Let me use black. So I can do it like this as well. Now, in this scenario, I definitely have a fairly high speed, the net speed of the swimmer. Correct, Namita?
Yes, sir.
Okay. What other ways can we get there? Different color again. I can travel in a direction perpendicular to this one. Now, this is my new V relative. By the way, let me just, for the sake of maintaining, now once again, if this is V relative, this is V river, this is your net speed with respect to ground. Correct, Namita?
Yes, sir.
Now, which one is the smallest? Right, which one is the smallest? Well, the blue one is the smallest. Correct, Namita?
Yes, sir.
Simple geometry.
Yes.
Got it, no?
Yes, sir.
Okay, good. Now let's look at this one, scenario A. In scenario A, if somebody says that the swimmer wants to cross the river in the shortest amount of time, then in what direction should the swimmer set off sailing with respect to the river? Once again, if the swimmer wants to cross the river in the smallest amount of time, then what should be the direction in which he or she should set off swimming at time from the shore relative to the river? Well, he or she should be traveling, the relative velocity should be pointed straight to the shore, the perpendicular to the shore in the other direction, as shown here. Now let me ask, does it intuitively make sense?
Yes, sir.
Yes, sir.
Let's understand in layman terms, if you were to try and explain, how would we explain it? Right? Well, the one way to understand or get a better grasp of the relative motion is first freeze the river in your mind, right? Assume that the river is not correct. And let's say the swimmer takes some time t to get to the shore. Correct, Namita?
Yes, sir.
River is not moving. Then they should travel straight in the direction towards the other, travel in this direction, right?
Yes, sir.
And the time taken would be distance d divided by this speed, v relative. Correct, Namita? Now he has reached here. Now turn on the river and let him float for the same amount of time. So he'll reach here, no? Right, so he'll reach here. That's another way to visualize the relative motion. First freeze the motion of the river, let the swimmer swim, and then add to it the motion of the river.
Sir, for the same time.
For the same time. Correct, no? So to cross in the minimum time, you want the maximum component of the velocity vector in the direction perpendicular to the shore. That's another way of saying it. Now, all the arguments that I'm making, they will start to make sense to you maybe in a much easier way 5-6 months down the road. As of today, a lot of these things would sound new. So I would advise, think through them, right? Build your own faculty to understand what's going on. Let's have a discussion next time. And if need be, we'll have another more discussion on the same topic. So we're gonna take a break here. Any questions before we call it quits?
No, sir.
No, sir.
So Vivita?
I'm good, sir.
You're good. All right, Vivita. You guys take care. I'll see you tomorrow. Let's try and start the class at 5:15 sharp tomorrow. All right, Vivita. Take care. Thanks. Bye-bye.
Thank you.
Thank you, sir.